everybody. Hope you're having a good time here at the conference. My name's Gary Russell. This is Gunnar Hillert and Oleg Zhurakousky. We all work for Mark Fisher, who's the lead for Spring Integration. And we're here today. We're going to talk about some of the major features that are going to be available in Spring Integration 2.2, which should be out shortly. We currently have Release Candidate 1 in the books. Release Candidate 2, we're just waiting for some final wrap-up on some dependencies, but that should be out shortly too. And then with GA, we're expecting within a couple of weeks. So, as I said, we're going to talk about some of the new features, some of the sort of major new features, and we'd like to. It's basically going to be a sort of demonstration of some of those features. Like to make it as interactive as possible. If you have any questions, then please interrupt as we go along. So actually there's actually five items we're going to talk about. JPA, Gunnar is going to talk to you about new JPA adapters that have been added to the framework. Oleg's going to talk about Mongo and Redis adapters, and I'm going to show you some new features for transaction synchronization, as well as adding advice elements to endpoints, and we'll get into some detail about that. There are some other minor issues as in the stored procedure work. There's a JDBC outbound gateway now, and the file adapters now support appending to an existing file. Okay. So let me switch over to STS. I'm going to talk about the first one I'm going to talk about is the sample is in the intermediate folder in the samples repo, and I called it retry and more. One of the common questions that we get on the forums are, how do I retry an operation? How do I take some action after an operation is completed? So, for example, when sending a file over FTP, having transferred the file to the FTP server, we often say, well, how do I then delete that file or rename it after the fact? Because by definition, the FTP outbound adapter, as I'm sure you're all aware, is a one-way component. This is sort of send and done. There's no reply comes back from sending a file over FTP. So the common approach for that was to make the final channel a publish-subscribe channel, and have the adapter be the first subscriber to that channel. When the file is transferred, then the second subscriber might be a simple service activator that renames the file. So this retry and more project demonstrates a new capability where we can now add behavior to any individual endpoint, not the entire flow. So the general capability of adding an advice, an AOP advice to any endpoint has now been provided, and we also have provided a number of standard advices. Retry is one, there's a circuit breaker advice, and then there's a generic spell expression evaluating advice, which is how we will do things like doing file renames and deletes. Somewhat related, but a little different, is the second demonstration that I'm going to show is the ability to synchronize operations with transactions. Now, I say it's related because another common use case is when we have a file polling inbound channel adapter, that sparks some flow. We take some action on, we've detected a file has appeared, we process that file in some way, maybe we write the contents to a database. The requirement is that then I want to dispose of that file after the fact. So after the flow is completed, I want to rename the file or delete the file, the input file. And that's achieved via what we've called transaction synchronization, and we'll look at that as well. It's related because there's sort of similar use cases. One is to rename the file on the outbound side after we've sent it. The other is to rename or delete the input file after the entire flow has completed. Now you might say, well, why weren't they handled the same way? Well, there's a subtle difference in that the outbound case started using a file inbound adapter. Perhaps it was a JDBC polling channel adapter. We create a file from the database and then we send it. So that the file we want to rename gets created as part of the flow. So that's why that is handled on the output side. So let's jump into it. So as I said, the general capability to add any advice that you want has been added to many of the endpoints in the framework. And we've provided 3 advices. So let's take a look at this stateless retry demo. So let me open up the file. So this sample starts with actually in this case just a standard inbound channel adapter. So we can type in some text in the console that's going to then invoke a service. You can see here we do a header enrichment. We add this failing ID header to the message, and then we invoke this service activator. And this is the new element, the new 2.2 element, this request handler advice chain. You can add one or more AOP advices to the, in this case, the service activator, but it could be many of the endpoints, such as things like AOP outbound, FTP outbound adapters. In this particular case, the advice that we've added is this retry advice, which in this case, I've actually used Spring 3.1 bean profiles to demonstrate different behaviors of the advice. So the default version of this retry advice is simply the out-of-the-box, the request handler retry advice. This retry advice builds on a project called Spring Retry, which began as part of Spring Batch, but was pulled out as a separate project because retry is a common concern across different environments, and so Spring Retry provides this basic retry mechanism, a retry template, which shouldn't be too much of a surprise. So that's a standard Spring mechanism, and the default out-of-the-box behavior is to try 3 times and then give up. It has no backup, and it doesn't do anything in terms of recovery. So in this particular case, the service that we're invoking, this conditional service, is simply a test method that if the payload of the message starts with the word fail and it has a number after it, then it determines whether we're going to whether this service activator is going to throw an exception or not. So it's a simple test that when he gets a message that begins with fail, it's going to fail. So I'm going to run the stateless retry demo, and oops. Why am I not getting in run as? What's that?
Scroll down. There's an arrow. No, just do what you did before.
Oh, it's just the screens. Okay. The application just loads in that application context that we began with, and so I'm just going to type in fail, and I'm going to let it try 3 times. And sure enough, the service throws an exception 3 times, and then we permanently failed it. Now, the permanently failed message comes out because if I go back to the inbound channel adapter, I'm sorry. I send the message to the failed channel. So when an exception is actually thrown back to the inbound channel adapter, we send a message on this failed channel, and that simply says permanently failed this message. So it's stateless in that the retries are attempted within the same context of the thread that's running. So let me go back to the console. This time I'm going to say fail 2, so it's going to fail twice, and then it's going to succeed. So you can see here, service failure. Within the context of that thread, we immediately retried it 2 more times. The second one failed, and the third one succeeded. So this advice is adding retry capabilities to an individual component within the flow. So this would be useful, for example, if you've got a JDBC adapter and maybe you have a transient database connection problem. So you just put a retry advice on that, and it will retry just that operation. As I said, this one's stateless. Spring Retry supports stateless and stateful retries. The stateful retry is basically the case where instead of retrying the exception or retrying the operation within the context of the current thread, the exception is actually thrown back to the originator, and then, so for example, if you're using a JMS message-driven channel adapter, you're actually throwing it back, causing an exception, doing a rollback, and then the channel adapter will retry it. Before we look at that, let me just look at these other profiles. So I said that out of the box, it just uses this default retry advice. I've also got this backoff profile, which uses the same advice, but now I give it a backoff policy, and I'm using an exponential backoff policy, where the first retry waits for 2 seconds before it attempts the retry, and we have this multiplier to exponentially increase the delay between retries. So let me just configure this test to use one of these other to use that backoff retry. And as I said, it's using Spring profiles from 3.1. So all I have to do is add Spring profiles active equals backoff, and
if you do not provide any profile, it will automatically fall back to the default.
Correct, and that's what I did. There was no Spring profiles active, and if I close this, you can see that the default profile. So the profile with the name default is the default profile by default. that can be modified too. So let's run it now. I'm going to run the stateless retry demo, but now we have a backoff policy. So now I'm going to type in my fail 3, and we can see by the timestamp the first attempt through an exception after, and then we waited 2 seconds, which was the initial backoff, and then the second one happened 4 seconds later. So that's the standard out of the box backoff policy, the standard exponential backoff policy that's provided by Spring Retry. You can write your own backoff policy, as with most Spring cases. It's just an interface. You can write your own backoff logic as you want, but there are a number of these provided by out of the box. So that's backoff with no recovery. Okay, so as I said, exponential backoff, no recovery. The final failure is thrown back to the inbound adapter, and the poller had an error channel. So that's why we got that permanently failed message. And then the final profile is the recovery. So in addition to adding a backoff policy, we also have this notion of a recovery callback, and we can decide what to do with this message after it's failed the configured number of times. In this case, we've also provided this error message sending recoverer. So instead of being thrown all the way back to the inbound adapter, in this case, the recovery callback is saying, okay, on the final attempt, or when the final attempt fails, invoke this recoverer. So I'm going to change the configuration to use that case, and so I just called it recovery. I'm going to run it again. Let's say fail 3 times. And again, there's no back off, but you see now instead of being thrown back to the inbound channel adapter, it's actually handled by this error message sending. So you could do anything with that. You can write your own recovery callback to maybe log the message or put it on a queue or do whatever you want. So you have the ability to take some action in the event that a message fails all its retries, and that's just handled by adding this recovery callback to the advice. In the case of stateful, let's take a look at the application context for this. Now, what I'm actually using I'm actually going to use Rabbit too. So when I type something in on the console, the standard in-channel adapter, I'm writing it to a Rabbit queue. I'm adding this message to give it a unique ID. One of the things about stateful recovery is we need something to identify the state. So when a message is resubmitted by the broker, we need to have some value that we can look up to see what the state of this message is from a recovery perspective. So what this is doing is it's adding a header called unique ID to the message, and then I'm sending it to a Rabbit queue. On the inbound side now, we have a message-driven adapter for AMQP that gets the messages from that queue. It actually sets this failing ID is something used by that service that throws the exception, and again I'm calling that same class to throw the exception. And there's just some Rabbit configuration. Again, I have the default profile. I didn't have the others, but in this case, what happens, because it's using because the advice has a retry state generator, that tells the advice that this is stateful retry. And basically that means that the exception is thrown back to the container, and the container will resubmit the message. So if I run the stateful retry demo, I'm sure I have it in my history here. So we have the same thing. It's I'm going to say fail 3 times, but this is going through AMQP now. So now we see a whole bunch of exceptions in the log, because instead of it just being retried internally on the thread, it's actually throwing the exception back to the container, and you can see here that the SMLC is saying that the listener threw an exception, and caused by this failure that I threw in my service activator, and it goes all the way back, but the container now resubmits it. So it's actually going back to the container. So we could do things like rely on the AMQP dead letter exchanging that's available now in newer versions of RabbitMQ, so that we can send messages to the dead letter queue in the event of a failure. So that's just a subtle difference between stateless and stateful retry. Any questions on retry? Okay. The next advice that we provide out of the box is an implementation of a circuit breaker pattern. Circuit breaker pattern is essentially, if you've got some service that's expensive to invoke, and it's not available. So for example, if you're going to connect to something over TCP, and for whatever reason the network is causing some delays in actually connecting, we might want to disable that service for some period of time. So the circuit breaker pattern is basically saying, if a service fails a number of times, then make it unavailable and fail fast for some other period of time, and then when that second period expires, then maybe we'll try the service again. So in the circuit breaker demo, this advice is calling that same service that fails. I've added the circuit breaker advice to the request handler's advice chain, and it's configured. We have these two properties on the circuit breaker advice. The threshold is saying how many failures have to occur before we effectively open the circuit breaker, and then how long do we wait before we attempt or we reattempt to invoke that service. In this particular case, well, let me just run it. So the demo enables us to type in messages, and it will fail depending on which second in the minute we're on. So let me bring that up. So as it says here, enter some text and return. So the service will succeed only in the last quarter of a minute. So let's just look at the current date. Let's see. So we're at 55. So let me just wait until we've gone past the minute. There we go. So if I now type in some text, the service has failed. I'll type in some more text. The service failed a second time. I've configured it to now for the circuit breaker will be open. So you see now it says that the failure is that the circuit breaker is open. So we didn't even invoke the service. We just immediately threw the exception because the circuit breaker is open. Now, I waited 15 seconds, and now it said service failed again, but now the circuit breaker goes immediately. So once it goes to this half-open state, we try one time, and then we'll immediately fail if it's still unavailable. However, and okay, now it's the 46th second. So now I can type in some text. Some data, and the service is actually succeeding now. You can see here. So the service is actually working again. The circuit breaker is open, but now it's going back to that closed phase, closed state. It's an interesting pattern, but there are cases where you might want to, particularly if there's some expensive cost. You might want to fail fast. And then the final one that we have provided is an expression evaluating advice, and this is the one that I mentioned about renaming files. So I have I want to open the. Let's look at the expression advice. So this is a file inbound channel adapter. It's looking for files in the temp dir, and then I'm sending it to FTP. Now I've actually got a mock session factory, so I'm not really doing FTP here. I'm really just emulating an FTP. But we have this FTP outbound adapter, and you see again that I've added this request handler advice chain, and we have this expression evaluating request handler. And that has a number of properties, the important ones being the on-success expression or on-failure expression. So now if our FTP transfer is successful, we're going to invoke this spell expression on our payload. In this case, we're going to delete the FTP file. On failure expression, we're just going to rename it to this payload, rename the file. We're going to append .failed to send to the file. And then the result of this expression evaluation is sent to, optionally sent to a success channel or a failure channel. And all I'm doing on those is I'm just logging those. You can see I've got a good result channel which logs at the info level and a bad result channel that logs at error. So let's run the on success case. File transfer delete after success. So I'm just going to put a file into this directory so that it I'm just going to touch a file in here. Oops. Did I not? Oh, didn't I? I hate using touchpads for. There we go. So I'm just going to create a file, just x.txt. In that directory, and you'll see now after the FTP succeeded, we removed the file. And I log the result of the payload.delete, and if I you see the file's gone. So it simply invokes that after success expression. Immediately in the case of a successful FTP. If there was an exception, we're going to rename it. So let me just run that case. So again, and I'm going to touch. And we can see that the rename after a failed transfer was successful. And if I look in that directory, we see now we have this x.txt failed to send. So we renamed the file because the FTP failed. Any questions on that? So as I said, the three advice, the general mechanism is to add this request handler advice chain to your endpoints, and we provide three advices: the retry advice, which supports either stateful or stateless retry. We provide the circuit breaker advice, and then we provide this generic expression evaluating request handler advice that can effectively do anything when the operation is successful or fails. I'm sorry? Right. So it is an advice chain, much like the advice chain on a polar. So yes, you can list. So you can have a retry advice and a circuit breaker advice, and yes. Yeah, I mean, obviously it's important to get them in the right sequence, but they're just top to bottom. They're applied to that. So each advice really wraps the next one, which wraps the actual handler method. It's important to understand that the advice chain that you can add to a polar, if you added an advice, so if you got a polar, so if we go back to this inbound channel adapter, we could add an advice to the advice chain on the polar, but then the whole of the flow is advised, right? So if you've got, let's say, an inbound channel adapter that calls an HTTP adapter, HTTP gateway, and then we call another HTTP gateway, and then we do a write to a JDBC outbound channel adapter, right? If you put the advice on the polar, all of those operations would be retried. If you just have a glitch in your JDBC connection, you can add this retry advice just on the JDBC adapter. So now you wouldn't call those two HTTP gateways the second time. The second sample app, or new sample app, is this, again, it's in the intermediate folder, is called TX Sync, which demonstrates this generic mechanism now to add transaction synchronization to your endpoints. Now, Spring has long had transaction synchronization. It's often used, it's probably the most common use of transaction synchronization is to do things like synchronizing a JDBC transaction with a JMS transaction so that we can implement that best effort one-phase commit thing where we put the two commits as closely as possible together. But there's a general mechanism in Spring for synchronizing operations with transactions. So when the transaction completes, we can either take a rollback action or a commit action after the transaction is completed. We've added that to Spring integration. One of the common use cases for that is things like you might want to delete a mail message from a mail inbound adapter. You might want to rename a file that was found by the file inbound channel adapter. And that's basically what this this sample app does. So we have a file inbound channel adapter that's looking for a file in this directory, and it has a poller that runs every half a second. And the new element on the poller in Spring Integration 2.2 is the synchronization factory element. And this factory is responsible for creating this transaction synchronization object that's used in Spring transaction synchronization. We provided a standard synchronization factory, and we have namespace support for it just to make it easy to configure. And it, as you can see here, it's got actions that can be taken as part of transaction synchronization. In this case, I have an after commit action. So if the transaction succeeds, we're going to rename the file to .succeeded. And if we have a rollback, the transaction's failed, then we're going to take a different action. I'm going to rename the file to .failed after the completion. So the file inbound adapter puts the file. We convert the file content to a string, and then we invoke this service activator, which is a simple service that writes the content of the file to a database. I have an embedded database, H2, and all this, all we're doing is basically writing the content to the database. Now let's just take a quick look at the this conditional service. I've got, let's see, 3. So all this service does is simply insert the content of the file into this table called foo, and then we do have the ability to throw an exception so that we can cause a rollback and do that. So let's take a look at this. So this particular demo is invoked by placing a file into that directory, and let's see what happens. Let's stop this one. So just for convenience, I made it easy to paste because Mac has this wacky way of naming its temp dir. So I'm going to put a file containing some text. And I've got login turned on. So what we see is the file was found, and we logged it. Let me see. Now the other thing I didn't show you in the console is that just to sorry, not the console, in the config file, is that I also have a JDBC polling channel adapter that's actually reading that table so that we can actually print out what was actually stored in the database. So you can see here it's actually saying bar equals bar because that was the content of the file that I just passed in. So let me just do another create another file. I'm going to say baz. Oh, I've got to give the file a different name, of course. And now we can see we've got bar and baz is in the contents of the database. So the contents of the file. Now if I remove that X text because that wouldn't have been found. If I list the contents of that folder now, you can see we've got X text succeeded and XX.text succeeded. So it renamed the file to the succeeded. Now what I want to do is just is actually put the service will actually fail if the contents of the file begins with fail. So let me do that. I'll just give it a different file name. XXX text. Now if I list it, you see now XXX test failed because the service threw an exception and caused the transaction to roll back, so the database didn't, the write didn't happen to the database, and we renamed the file to append fail to it, so the exception failed, and there we go. Excuse me? Well, so the rollback happened. If you see here that my service threw an exception, forced exception, that actually caused the transaction to roll back, and then, oh, in the code. Oh, sure, yes, yeah. So all the service does is if the contents of the file starts with the word fail, I just throw a runtime exception. So that causes the transaction to roll back. In this case, I don't need a transactional annotation because we're actually starting the transaction in Spring integration. So if we look at the configuration, I actually have the polar is transactional. So when the polar finds the file, it starts a transaction at that point. Now I could have an @transactional on there, but it would, it would be, unless it had require. Well, if it had requires new, then it wouldn't be the same transaction, right? If it was a default propagation, which would be required, then it will participate in the same transaction.
But if you don't start with a poll, let's say you have a typical messaging gateway with a service interface, then you would annotate the interface with a transaction.
Right, right. But then you wouldn't have this ability to take some action after the, this is to synchronize. I mean, in order to synchronize the file renaming with the transaction, to do it, one way or the other with success or failure, is you have to start the transaction at that point, not when we hit the method. We have to start the transaction. That's when the synchronization actually takes place. And the other thing I mentioned here is you see we have after commit, after rollback. Spring transaction synchronization also provides a before commit action, so you can actually affect the transaction as well. So for example, if you wanted to rename it and that rename failed, you could throw an exception, and that would cause the transaction to roll back. So that's a third option on the transaction synchronization. Yes. So this is all in the it's currently up there in the samples. So if we just go to the GitHub, the Spring integration samples. Let's see, Spring integration samples, and these are all in the intermediate package. And you see here, retry and more was the retry advice, and the TX sync is the transaction synchronization project. TX sync, yes. You see that's the transaction one, and then this is the retry advice. So the samples at the top level has got advanced applications, basic and intermediate. These are all in the intermediate folder. I probably ran over, so I will. Who's next? Oh, any more questions on this stuff?
One question: this Spring Retry project you were talking about, essentially we can use it in other module other than Spring.
Yes. Again, it's on. Sorry, it's on GitHub, and it's just called Spring Retry. As with the standard Spring terminology, there's a retry template which has a method do in retry, and that's how it works. Okay.
Okay. With that, I would like to cover some changes around, or we added JPA support in Spring Integration 2.2, and maybe just in that regard, I also want to do a quick recap on the support we have with the 2.2 release in regards to persistent option for relational databases, particularly for the adapter support. So we had JDBC support for the longest time. We actually made an improvement in 2.2 in regards to JDBC support when you're using the outbound gateway. So if you like, for example, the way of abstracting your business layer code by using a gateway to provide just a plain interface, but yet you would like to retrieve data from your database using the provided JDBC gateway support, the outbound gateway. Before historically you had to basically, it was assumed if you do an outbound gateway that you would like to persist the data. So you would, basically the message payload would be the document data, and that's the one you would like to persist into your database. With 2.2, we went the route, and that was kind of like a requested feature, was that, well, I also would like to retrieve data. So basically I have certain conditions on my kind of like use the payload as a command message, but I would basically like to retrieve user with an ID, blah, whatever, with certain other parameters. So it was basically, instead of just doing an update, give the users the option to make that update optional. So that was added. So you can now also retrieve data as well using the JDBC support. In Spring Integration 2.1, we also added support for stored procedure and stored function support using the underlying API that the core Spring framework provides. And we improved in that regard for 2.2 also of the ability to add stored procedure names dynamically at runtime. So you have that support, the JDBC support, stored procedure, stored function support, and then also in 2.2 we added the support for JPA. And what we did in that regard is we created a few several new adapters, the JPA inbound channel adapter, the outbound channel adapter, the updating outbound gateway, and the retrieving outbound gateway, kind of like similar to what we have in the JDBC support, that depending on the use case you may have different semantics of like I want to persist data, yet I would also like to retrieve data primarily. So there are certain semantic differences that made it ultimately the decision to split those up into individual components. For the example, I would like to show fairly simple, just having a gateway that allows you to list users from the database or add new users to the database. In the provided JPA support, we tested it with Hibernate, Eclipse Link, and OpenJPA. If you're in the business of writing transferable GPA application that worked with different GPA providers. It was certainly an interesting learning experience down code to Hibernate, because Hibernate is so much more forgiving than anybody else. So that was just a quick side note on that. To jump into the code, also those samples are in the samples repository under it's under the basic folder GPA, and in my main class here, what I have is it actually allows you to select at runtime the various persistence providers. So the example will work with Hibernate, OpenGPA, and Eclipse Link. What I do is basically just provide, I'm setting the various profiles for the respective Spring application context to set up. So for Hibernate, which is the default, I'm also basically setting the active profiles for each of the persistent provider. All I'm having here is kind of like my business interface, my person service, which I can operate off finding people and creating people, for example, down here. The context, we have, as I said, my gateway here, depending on which method I'm invoking on the person servers, I'm sending it to the create person request channel or list people request channel, which then goes either to the retrieving outbound GPA gateway, or in the case of persisting people, I'm going to the updating outbound gateway. The person itself, just a super simple persistence entity, maps to the people table. All I'm having is a name, ID, and a date. I'm using by default here an embedded database, H2, for my persistence. So when you check out the sample, it will run basically immediately. All you need to do is check it out, build the project, mbn clean package. It will create, build everything up, and then just do mbn exit. So basically what I'm doing here, which just kind of works kind of nicely also on the side note, is using the Maven execution plugin, because I just need to point certain things out here. Basically it allows me to start just the main method, but I'm also needing, in order to provide support for OpenGPA and or Eclipse Link, I also need to have the runtime Java agent running, basically to provide to do the how do you say, the basically provide the persistence information at runtime if I don't want to typically need to compile those in before in order to work with either OpenGPA or Eclipse Link. So I'm providing those here as well. So with that, I have like, let's use Hibernate. I can list all people that are currently in there, which I'm assuming is just Cartman. I can create a new person, which is, let's call it, I don't know, Mark Fisher. Say no.
It actually exists. You don't have to create.
I'm adding it to the database. And I can do list all people, and my persistence data is returned from the database. So that's kind of like the basic support for JP that this sample provides. And there's, of course, you can use the provided GPA support not just for GPA persistence. So it pretty much supports, it provides all the supported GPA functionality. So you can use it to not only execute JPA, but you can use the persistence query language for JPA. You can execute native SQL query, name query support. You can provide this as well. You can, when you provide, parameters, positional as well as name parameters for your JPA queries. There are some requests from future versions to potentially add persistent store, message store support as well, but that's not currently in there. So so that's kind of like the JPA support we're providing right now. Questions from your side? Or is everybody already switching over to NoSQL? Yes. Oh, that's for the, you're talking about specifically about JDBC support or JPA support? Yes, on the JDBC support, you have the ability to basically get the last inserted ID and use it further downstream or for select queries, etc. So yeah, you have access to that. Yeah. Okay. How are we doing on time? Do we still have? So that's my sample on this side. I just want to point out a quick example, which I'm not going too much into it, but which I had fun writing. We had the ability to also now add, when you have an outbound file adapter, it was at times maybe frustrating, and the workaround was maybe not as obvious, to write basically to dynamic directories at runtime. So you basically, based on header information, you would like to store files, for example, in various subdirectories potentially, or also create those directories at runtime. There's with the added support into 2, there's also a mail attachment sample. So when you have more theoretical exercise of basically having emails within an email, with attachments, with other emails in the attachment, with images attached to them, etc., the whole 9 yards of recursion. So there's a nice little example that basically parses, pulls an email account, gets the emails, parses out all the information that's in the emails, and basically spits them out based on the email attachments and basically in the subdirectories, etc., using dynamically creating directories. So that's a nice little example if you have need for that. Just want to mention it. I certainly had fun writing it. So with that, I'm done for my part and would like to hand over to Oleg.
Hello, check. Okay. Right, good morning, everybody. I guess I'm going to finish off with showing you other new things that we have in Spring integration, and you kind of also seeing the whole parade of Spring integration developers here. So that's pretty much the entire team. Well, not quite. We actually have one pretty steady community contributor out of Ukraine. So he's not here, but you know, he's a frequent, well, more than frequent committer. And of course, something happened with my display on the previous presentation, and I'm having these major problems. Yeah, well, I got to tell you what happened. Oh, it worked. Okay, so sorry, I was presenting in a previous talk, and I had an accident and kind of resetting all my windows right now. All right, I'm good to go. So Gary talked about a lot of new things. Gunnar talked about new things. So the problem with new things is that we we first introduced a new thing, then we introduced a new documentation, we introduced the blogs and everything else. But a lot of times you want to get there as quick as possible. You can't, just like me, like you can't wait till documentation comes about. Like, how do you learn stuff? How do you learn stuff within Spring integration? How do you learn about these new things after you heard about them or you discovered them from the commit logs or something like that? So what I decided to do, instead of creating the separate demos, I mean, there are samples already for MongoDB and Redis stuff that I'll be talking about, but I kind of wanted to show you the different way of sort of learning the new stuff and say, listen, why don't you just go straight back to the test cases that we have within Spring integration? And again, I'm not going to wait till I completely check out the project and configure the workspace, but it's as simple as just going to the GitHub, say git clone project, and you have the entire source code. And we actually have on the GitHub the rest of the direction. If you click on the wiki, the rest of the directions on how to contribute, how to get started within your development environment, and we'll actually publish a more comprehensive one, how to get started with the development environment. And once you have a development environment, then you have everything at your fingertips, and the only thing you really need to know is how to navigate our project structure, because we have very strict sort of guidelines and rules into which type of test goes to which type of packages. Once you know that structure, finding the actual test that you're looking for is never a problem, and that's how quickly you can, that actually will speed up your learning process of learning something new. For example, the first thing we're going to be talking about today is Mongo. So before I get into the details, how many of you know what MongoDB is? How many of you use MongoDB? All right. How many of you are planning to use MongoDB? All right, good. So, so MongoDB is a document store, and there was plenty of talks on in Spring 1 about this from Ali, from Mongo vendor. They're here. So it's a pretty interesting way to store data, to collect the data. So everything is stored in a JSON. It's a document store. You can see it. You can query it on any. It's a JSON with key values, basically a map, so that you can query it on any key because you don't really need a specific index and things like that. So, and how many of you see that funny video on YouTube about the web scale? Yeah, it's a web scale database. So, so now, obviously, Mongo support within Spring integration comes in two flavors. Since it's a store, we obviously have what? A message store implementation of, right? So we have a MongoDB message store implementation. And since, again, it's an external system, we obviously have inbound and outbound adapters, right? So why not gateways? We didn't get a requirement for them yet, that's all. In fact, what I just said means that obviously we can implement something that reads and writes, reads and writes, and kind of gives you some kind of response back, some process like we just don't have a real use case. If you, the community, you start doing something and you have a use case, please feed us back through forums and we'll implement it. But anyway, so first, the message store. I'm not going to run. I'm just going to show it to you for now. So how do you find it? So first of all, here's your this is my workspace. My development workspace. So here's we have many different modules. Mongo is one of them. And here's MongoDB. And you go to test package. And once you go to the test package, you will see, as you can see, there's several packages. We'll have config, inbound, outbound, and then store. You might see other packages, but the ones that you'll be generally looking for is almost every module will have a package that ends with a config, and I'll explain you what that is. And almost every module will have inbound and outbound. You probably assume that's where the adapters are. And then since it's a module that deals with a backend store, it obviously will have a store package if we have a message store implementation. So how would you find a test case to learn more about MongoDB message store? You would go into the store package, right? So you would find the implementation of it here in the main, but you would find the test cases about this right here. And once you go into the MongoDB message store test, right, you can actually, the other thing we do, we try to name our test cases very descriptively, right? So you can actually get a description of what this test does and also an exposure to how you use it with an API. So, and essentially getting yourself tons of samples of how to use, in this particular case, MongoDB message store, right? So now, what I really want to show you is the newest feature of Mongo, which is the inbound and outbound adapters. But now, since you already know a little bit about our project structure, how would I know? Here's here's an interesting thing. You want to learn about how to configure inbound channel adapter. Where would you go? MongoDB inbound channel adapter. Where would you go? I'll have you a second question. If you want to learn about the implementation of MongoDB message handler or message source, where would you go? Remember, message source in, message handler out. So now the answer is that for the actual API, for the actual implementation, you will go to the outbound or inbound. But you can see there's no XML, there's no configuration here because this is where we're testing the actual underlying implementation. So if you really want to get into and learn a little bit about our API, that's where you would go, right? Now, but if you want to, if you want to find out about how to configure MongoDB message store, not message store, or even message stores for that matter, if it's XML configuration, or you want to find out how to configure inbound or outbound channel adapter, or any inbound or outbound channel adapter of any project, right? You will go to the you will go to the config package. And config package usually have the most test cases. And because they have a lot of Java files and they will have a lot of XML files because these are all various different scenarios that we are testing. And what I want to show, so here's you can see MongoDB inbound channel adapter integration test, and this is another pattern. You will see integration test versus parser test. Parser test merely evaluate that if you set the attribute to value foo, then it's indeed foo when you got yourself an object, right? A lot of times there's a mix that we can actually run something, but quite often there is no running. We actually, if it's a lifecycle class, we say auto start false because we just want to initialize the object and check that the values are set. But if it's an integration test, we're obviously doing something. So now testing with Mongo and Redis is a little bit complicated because in order to test it properly, we kind of have to have Mongo running, right? So in this case, I have, by the way, the project checked out, so we can run, for example, gradle clean Eclipse, right? If you're using IDEA, it would be clean IDEA, and that's it. At this point of time, you can just import the projects into your workspace. I can guarantee it will work, okay? But I'm not going to do that. So my MongoDB is running right now. It's spitting out messages every now and then, right? And I have this basically a Mongo command line utility, which I can actually go to command line and execute queries on MongoDB right now. It's empty because I'm starting it up and I'm making sure that it's absolutely clean before I start running any test, and I'm cleaning it up after I run the test. So where are we? Let's forget about Redis for now. So all right, so I went and I found this file, outbound adapter config, right? And you can see, let's look at this file more closely. So what we see many different configurations. So we're kind of saying simple adapter with name collection. So you can kind of start noticing that there are several different scenarios. No, this is not one configuration that we're testing top to bottom. In fact, there's each adapter kind of represents, in this case, a separate message flow. This is just a combination of all various different test case scenarios, right? And then you go to the corresponding test case, right? And the corresponding test case, you can see that we are indeed bootstrapping this file, and I'm being called simple adapter, which is this guy, right? As you can see, this is a very basic configuration, and then I'm sending basically a message channel. Since it's an adapter, how many of you knew that? Since the channel adapter, sometimes people are confused about that. Like, it's a channel adapter, right? There is no channel, it's just channel adapter, right? But when I retrieve it, I cast it to channel because it is a channel. It's a channel adapter, So if you really want to get to the underlying class, you would do, was it adapter.sample, Gary? Or sample.adapter, I keep forgetting. Anyway, so now I got the channel, and I'm simply creating a message. Again, the configurations here are very simple. Yes, I could put a gateway. Yes, I could put something fancy around it. But I want to really test the raw functionality, so I don't need to complicate the issue. And that's why it's actually a very good tool for learning, because you get the bare minimum of what's required. And then you can build your stuff on top of that. So basically what I'm doing here, I'm sending a message, and eventually now I have to validate that the message was sent, right? So which means I have to read it. Well, I could read it with an inbound adapter, but when I was writing the adapter, I actually started with an outbound. I didn't have an inbound, right? But at the same time, I really only want to test the outbound side. So for the outbound side, I am using Spring integration, but for the inbound side, guess what? I'm using Spring Data Mongo. The adapters themselves are built on Spring Data Mongo project, but it would not be appropriate for me to actually, within the outbound adapter test case, to start using an inbound adapter, because now I'm creating this cycle, because then I have to do the same for the inbound, right? So I'm actually relying on the raw template and kind of verifying that if somebody who does not use Spring integration, will they be able to read this data? So kind of accomplishing two goals. So now let's run one of these tests. In this case, we're running this very simple configuration. We're relying on defaults, which means the database is going to be data. That's the default name. And again, all the information is available with documentation. The collection name is going to be the default. Everything is going to be the default. The MongoDB template that's going to be Bootstrap is going to be the default one. So all the things that you really don't have to worry about. And obviously the MongoDB factory, configured right here using Spring Data Mongo, and obviously points to the local host, but you can override it if it's running elsewhere. So let's run this test case. I want to show you something. Come on. All right. It ran, right? Did you see anything cool in it? No, you didn't, because, this is just a test case. We have assertions that validate that everything is there, right? But I don't know about you, but every time I try to learn something from using this approach, like using the test cases, I love my system.out at print line. I love to see something in the console. It just gives me that warm and fuzzy feeling. So what can I do from this test case? How about I'll just get this guy, the whole thing. Well, how about I'll just convert this assert not null to right? So now what I'm doing, I'm using a template to do define. Obviously it was returning something. For this particular test case, I didn't care what it returns as long as it returns me something. Although maybe like Gary would say, well, how about you also validate that all the fields are right and everything. So, but we can do that as well. But for this test case, for example, I felt that maybe it's just enough, right? But now I want to be able to see it just so I can feel much better about that. So, well, actually, don't have to do that. So I can run it, and it's empty because, you just saw. I know it's not empty, but because I cleaned up the database, you just saw how we discover bugs in tests. So seriously, Gary, make that note. I have to fix it. So anyway, no, seriously, it's a bug because I'll show you that the data is actually there. And it's kind of funny because you can actually see that it's everything is volatile. And so what I expected to see, I would expect to see something coming out of here. Well, I did get something. I got an empty array. Well, so let's let me show it to you in a different way, because and it's essentially how I was validating, and maybe now I'm going to say, you know what, I should have go to a more conservative approach and actually get the data, get the object back, and validate that that everything is there. In all probably that's exactly what I'll do. But how can I show you that everything actually does work and works okay because I'm testing that the data ended up there? Well, all I need to do is I put a breakpoint here. I have a command line. As you can see, I'm executing a find on a database. There is nothing there. When I execute debug right after this channel send, because remember, channel send in this case equivalent to Mongo template.store, right? And I go here. That's interesting. Because as you can see, I was just like playing with this earlier. That is very interesting. I need to figure out. It could be because the way my Mongo was starting this morning wasn't really clean. So, all right. Well, I will investigate that because I mean, obviously, it works. Oh, here we go. So I need to restart Mongo. Something went wacky on the Mongo side, maybe. I don't know what. So let's just see. So I still have to fix that problem, but as you can see, this is how I can learn something. All right. So just to speed up the things a little bit, I can go to the same package and find MongoDB inbound channel adapter integration test. In this particular case, so again, we can sometimes you can actually look at the test case, look what file it bootstraps, go find that file, inbound adapter config, and kind of look at the configuration. And in inbound adapter, so we have it's a typical inbound channel adapter which reads from Mongo, and you got yourself your typical channel. Now, since as you can see, Mongo allows you to execute queries. You can specify the query here, or you can provide it as an expression, and so on. So let's look at the test case here. Again, I'm using Mongo template to actually create, so it's kind of the opposite approach. We're using Mongo template to actually create the data in a Mongo, to populate it with the test data, and then I'm bootstrapping the Spring application context and doing all my assertions and things like that. All right, any questions? So in a quick summary, with Spring Integration 2.2, we're coming out with MongoDB inbound and outbound channel adapters, which allow you to write a message payload to the MongoDB message store, right? And we also have MongoDB message store, which we actually had for a while now, which allows you to write a message to the message store. That's a difference between adapter in this case versus a message store. Okay? Nothing? Moving on to Redis. So now, so obviously there's also a blog on the Mongo that we just you guys probably noticed we came up with a series of blogs recently. So it's a part 1 with Mongo, then Gary did part 2, and then Gunnar did part 3, and then Gary did part 4, and I'm going to do part 5 as soon as we release RC2, so we can do the Redis thing. So because we found a few bugs in our RC1 that we had to fix. So we're coming out with a lot of these new things, and you can read about them, but you can also learn them the way I'm kind of showing it to you. So now, since you know all this stuff, so again, as you can see, I'm in Redis right now, but if you look at the package structure, again, it's the same package structure. So you want to find out how the Redis collection populating message handler test work, or message handler works, you go into this package and you find a test, and the same goes for the inbound. But enough of that. So let's look at what are we trying to accomplish with Redis. How many of you use Redis? Crickets. All right. So Redis is a key value store. It's another one of those NoSQL movements, so it's a key value store. So unlike Mongo, which is a document store, stores everything in JSON, Redis is a key value. So everything is kind of like mappish. So you have this collection that is a key, and the value could be a lot of different things. So let me show you one example. So let me just give you the outbound so you can see what can we store in Redis and how can we store that. So again, I found the outbound adapter test, and we have all these different scenarios. And you can see that we kind of, again, very self-explanatory. So we have this Redis store outbound channel adapter. So it's storing something in the Redis store. But what can we store in the Redis store? Basically, whatever is supported by Redis. And what's supported by Redis is these 5 different collection types. So you can store. So it's kind of interesting because you can have the Redis itself is a key value, but the value could be one of these 5 things, and the value could actually be a map. So it's kind of a key where the value is, it's a map where value is a map as well. So so in this case we have list, we have zset. I'll show you in a second what that is. We have map, we have set, and we have properties. Okay, so these are different collection types, and configurations are very similar, but certain different collection types gives you certain different capabilities. So let's look at some of the test cases and kind of see what they do. And I kind of want to show you the list because list would be very similar to set. The only difference would be the difference between the constraints of a list and a set. But then I want to show you kind of another thing called zset, which is a sorted set. Where items in a set could actually have ranks, so you can eventually increase the ranks, decrease the ranks, and do these interesting things. So let's look at the Redis collection outbound channel adapter test. And so again, in this you can quickly see that I'm bootstrapping it from this file. So if you didn't know how to correlate the XML configuration file to a particular test case, go into the test case and you'll find which file, because sometimes a single test case can correlate to many different files. All right. So we bootstrapping this context, and what we're doing here is we're using this list with key as a header, right? So our key, so we have, sorry. Where is the, okay, let's just look at this one, the first one. List with key provided, right? So our key is going to be the Pep Boys. And what we're going to be storing is a collection of 3 individuals, Manny, Mo, and Jack. I used to work for Pep Boys, so kind of memories for me. So, so basically we're creating a typical Java list and creating a message with that list being a payload. And we, again, sending it, this is the beauty of Spring integration. You might read a book or go through documentation of how to use the API to store data in Redis or Mongo or whatever. But as you can see, when it comes to Spring integration, it doesn't really matter because the code here actually looks pretty identical to the code we just saw in Mongo. Create a payload, create a message, send it to a channel, and that channel is hooked up to that adapter or it's exposed as an adapter, okay? So in this case, me sending a message to the channel signifies that I'm going to be storing this message in the Redis store. Well, again, at least I'm here I'm asserting for something more substantial because since I inserted 3 individuals, I want to make sure that the 3 guys are there, right? So I'm asserting for 3. But again, in this particular test case, we probably, again, while learning, want to be able to see something. So the interesting thing about Redis is that the way Redis is implemented is that you have a very interesting API, and one of the elements of this API is this concept of a Redis list, Redis set, Redis Z set, and things like that. What that is, imagine, because the immediate question would be, since I am getting the entire list, well, yeah, when I have a list with 3 items in it, that's not a big deal. But what if I have a list with 3 million items in it? Do I really get the entire list? And the answer is no. So what this Redis list is, and we'll see that because that's the payload of the inbound side when we read something. What Redis list is nothing more than a pointer, basically a handle that's already initialized with Mongo template and everything else. It's a handle to Redis, right? So you can operate on it just like on any other list. You have the same type of methods like iterator and things like that. But when you get an iterator, which I'm going to do in a second, what you're doing is iterating and you're actually pulling items from the list. You're not getting your 3 million list into the memory. You're not loading that into the memory. So, so what I'm going to do instead of doing the simple assert, let's just see that I really do have many Monjacks. So I'm going to do iterator. Let's just call it iter equals Redis list dot iterator, right? So in this particular case, I created Redis list with the Redis template and everything else because, again, remember, I'm testing the outbound side, so I had to validate before that there was nothing there, right? But when we're reading it on the inbound side, that's exactly the piece of code that is used by the inbound adapter to actually create it. So, and right now I'm just going to do while and so am I. Let's run it. And we got to solve a minimum and jack. So that's how you can quickly start learning things like that and see what's going on. So the same goes for the outbounds, for the inbound side. So we have Redis collection inbound channel adapter integration test, and you can go again into the inbound file and start reading the data from the Redis. Now, quickly about the ZSAT. So ZSAT, so you can see the differences. In this case, here we're testing the ZSAT. Remember I told you the ZSAT has the, and again, I'm sure there's going to be some Redis presentation, spring data presentation that will cover Redis in more detail. But the ZSAT gives you the ability to rank your, to give a score to your elements in a set. So in this case, the test case that I chose to basically creating so I'm creating a map with presidents, and basically whatever the count of the president was at the time, that essentially is the rank. So here we have, so it's not really a true score how they performed as presidents, but just the fact that Barack Obama is the 21st president. So that's actually no, that's not the 21st president. That's the century in which they operated. Sorry. All right, because otherwise I have 3 presidents, 19. Yeah. So essentially now, so you'll be able to when you go into the Redis console, when you perform the read operations on the Redis, you actually be able to say, listen, I want to be able to get all the presidents from the 19th century, and that's essentially what we're testing here. So you can look at the test cases, and you can, again, get Redis ZSET, and because the ZSET, now you have methods like range by score and so on and so forth. But again, the convenience is that Redis ZSET or Redis list, all these objects, they do not have, they're not loaded in memory. They don't have a data loaded in memory. They're just pointers to the actual data. We have pretty much done. We have 3 minutes. If you guys have any questions, let's get on it. Yes?
When is the 2.0
2.2 GA, that's a good question. So we are going to be releasing RC2 pretty much right after Spring 1. We wanted to do it before Spring 1, but there was a few issues, like Gary mentioned earlier, with the dependent projects that made us postpone the release. But basically, release candidate 2 is imminent, and what we say, like 2-3 weeks after? Yeah, 2-3 weeks after. So hopefully it's going to be before Christmas.
Also, if you would like to hear more details about, since the 2.2 release is imminent, already getting an outlook onto the 3.0 release that we will start working on, please join us at 4:30 p.m. for Spring Integration Batch Data Lightning Talks in Columbia Hall 3. So that's probably a good point then, since we're right at lunchtime, to talk some of the planned features for the 3.0 release cycle that's following. So.
Yeah. So I'll take that question. So I work on I'm working on the Scala DSL, as you may have known, and yes, we're thinking about providing a Java alternative to configuration. But I always like to point out that when it comes to a project like Spring Integration, I actually, like, this is, of all projects, I mean, this is really the one where actually a strong believer that external configuration has more value than internal, configuration. Although for some things, for something very simple that you want to configure kind of like inline, but still benefit from the, the EIP, there might be a value in it. But, so we are thinking about this, and in fact, we're more than thinking. There's a few prototypes floating around, and actually been floating around for quite a while now.
So that's certainly on the radar for the 3.0 release cycle.
Yeah. Any more? Yes.
So I noticed not too long ago in Spring Source Tool Suite that the diagramming view for Spring Integration was no longer supported, but then you could still kind of set it up to access it. Is that going to continue to be the case?
No, the diagramming support is in there, so that's working. There's some issues still for the 2.0 release, so there's some open issues that need to be resolved for 2.0, but the support is certainly still in there.
It's still continuing?
Yes.
All right. Thank you, guys.